standing right beside me. Also standing beside me is Mr. Liu Huating, an engineer from the State Grid Zhejiang Electronic Power Company. So good morning, Huating.
Good morning, Mr. Chen.
Well, here we are, right? What is this? What is this giant stuff?
Yes, as we can see, this is our tallest electric tower. And this project is called Zhoushan 500 kilowattage network connection project. And every time I see this tower, I feel shocked. I feel shocked and amazing because I think it's much more than a tower, but it's a great construction with our wisdom and hard working.
Well, with wisdom and hard work. So, what is it for? So, what is the objective of building a tower like this?
Yes, you can see these towers, there are lines between the towers. And the length of line is about 39 kilometers. And the lines between Zhoushan City and Ningbo City, so it guarantees the development of Zhoushan and Ningbo and to provide electric and to provide the needs from Zhoushan to Ningbo. And as we can see, the 14 is sea crossing towers because it's crossing the sea.
So 41 in Zhejiang province alone or 41 across China?
14 is cross the sea and the other
71. 70 in Zhejiang or 70?
71 in Zhoushan.
71 towers like this, but not as tall as this one.
Yes, because 380 meters towers are just these two.
Okay, so we talk about its height. I've learned that it's 380 meters tall, almost 4 times the height of London's Big Ben, and even taller than Paris Eiffel Tower. Why did you build it that tall? Why is it that tall?
Yes, it's no doubt. The tower is absolutely 380 meters.
Cool.
So why we build this tall? Because you can see this channel. The Zhoushan is the biggest city to produce and process seafood, and there are lots of ships through this channel. If we don't build this high, the lines between the towers will drop down and touch the ships. So it will be very, very dangerous.
We know that Zhoushan is home to many biggest manufacturing companies around the globe. Like we know Boeing is here in the Zhoushan Island. It is also a tourism place with Mount Putuo, attracting lots of tourists home and abroad. And it also has many urban areas. I mean, people are living actually in those islands. So making it clean is one of the objective and main goal of building this tower. Am I correct on that? And why it is clean, or why the use of electricity itself is clean?
You just said the point, because the normal way we transfer the electrics is by using the coal. But this way it has lots of disadvantages, such as it has lots of loss through transferring the electric, and it's bad for our environment. But by building these towers, we transfer the electric from the other place, such as Ningxia or Shanxi province, and we transfer electric from this place to here. And through these lines, just by these lines, it is almost no loss and no damage to our environment.
You told me last night that there are so many made in China elements, designed in China elements, and also innovated by China elements. What are they?
As we all know, it's the tallest electric tower, and it's also the heaviest tower in the world. It's almost 7,280 tons. We are the first time to use helicopters to build the towers to string the cable. Because we all know that there are many islands and mountains in Zhoushan, and the weather is very bad, so it's difficult to build the tower by the normal way. I have made lots of foreign friends, and when they first come to here, and they are just like me come to here first time, they are shocked. And
Why they're shocked?
because in their country, their normal towers are just 60 or 70 meters, and they have never seen this tall, and they think they are not just think the tower is amazing, but they think our workers is amazing.
You said the foreigners are also amazed by the Chinese workers. You are an engineering student, and now you are an engineer.
Yeah.
Have you climbed that tower?
Sure.
Oh, how many times?
Maybe 4 to 5 times. The most part impressed me is when I first time come to the top, because I never come to that high, and there are very strong wind. Maybe the wind can blow me out if I don't sit my seat belt. And
But you did have your seatbelt.
yes, I have, because before we climb the mountain, we must do the security. It's about our work, about our life.
Did you fear?
Everyone fears, but it's our job, it's our duty. So we must do this job done, and when we get this job done, we feel very proud because we guarantee the local people's safety, electric safety, and we provide the needs for the development. So we are very proud.
Thank you for your dedication. And also, one last question: when did it complete, and when will it be in use?
Next week it will get into use, and it must make people, the local people, make they feel more comfortable their life, and they can enjoy the electric more easier, better, and cleaner. And through this year's effort, all the workers are very proud because we make a very big contribution to the local people, to our country, to China.
Sure, you did. Okay, thank you very much, Wating.
You're welcome.
Thank you. I'm Chen Chen, now live in Zhoushan, China's eastern Zhejiang province. So our next guest, Mr. Xu Xiaoming. Good morning, Mr. Xu Xiaoming. 早上好，徐老师。Well, I will ask Mr. Xu the question in Chinese, and I will translate it back to English while I'm talking to the camera. So, and I heard that Mr. Xu has also built a very similar tower in Brazil. So, let's take a look. 所以说，徐老师，我想问一下，平时您在作业的时候，身上带的设备都有哪些 ？I just asked Mr. Xu what facilities does he bring up to the tower?
那个全方位的护腰带，还有腰绳、安全绳，这是我们所称的那个生命绳啊。高空作业必须要佩戴这个安全绳作业。
So Mr. Xu said that he must have the safe belt with him whenever he climbs up to the tower, and the engineers here also called the safe belt the life belt. 还有哪些 ？What else?
就我们除了全方位护腰带以外，个人的安全用具以外呢，还有个人的那个工具，小工具，扳手啊，那个老虎钳、 还有装肩杆棒的专用工具这些东西。
And among other kits like the hammer or any other things. 徐老师，您的工作内容是什么 ？What's your job in the construction of this tower?
我主要负责这个380米高塔，从立塔开始到架线，所有的负责指挥啊、协调工作。然后下面的高空作业呢，现在是在那个进行消缺工作，然后现在附件安装啊，其他设备各个设备的安装，就是这些。
Mr. Xu said he's in charge of all the process from the base to the top of the tower, and now the priority lies in the check of the cable. 您刚才说的消削是指
因为我们就是验收出来，不是做好以后，它有部分有的质量不是很好，验收出来还有问题，所以要进行把这个所有的缺陷给它消缺掉，就是把有问题的地方给它处理好。
所以说，用更通俗的话来讲，就是检查电缆的这个
是否有损坏，是否有就是电线上面有没有损坏啊，这些东西，各个电器，就是我们带电这个设备上有没有东西少的或者缺的，或者有没有磨损啊，这个东西我们要进行后期的进行处理。就是
Ask Mr. Xu, to ask him to specifically talk about the check of the grid, and he said this is a very last step in making sure the cable will be in full use, and they have their workers on the line to check every spot of the cable. 这一定是最辛苦的工作之一。
这个工作肯定是非常的辛苦，像我们今天大雨雾在上面，像我们现在地上面没雨，上面高空上380米是因为那个雾水都怕把我们施工作业人员打湿掉了，所以很艰辛，还要跑线出去要走将近2000多米出去，高差从最高点到湖水点有220米的高差，这个爬坡脚有20度。有人要这样徒手爬上来，所以非常的辛苦。
I said that the check of the grid must be one of the most difficult tasks in the whole process of the construction of the tower. Mr. Xu nodded yes and said, some workers even have to climb a slope of almost 20 degrees, and it is really hard working thing. 徐老师，还有一个非常重要的问题 I ask you another important question. 这座塔和您之前经历建设的，就像我刚才之前提过的，您在巴西也参与建造过，可能是类似的这种电塔。这座塔有什么不一样 ？I just asked Mr. Xu that he has worked in Brazil and built a similar tower. So what is the difference of this tower from that one?
这个塔跟我们原先在巴西亚马逊那个南美第一输电高塔不能自入，它是一个高度。
那个多高？
那个是296米，
差一点。
对，现在这个是380米，现在这个塔呢变成世界第一输电高塔了。那么包括它的重量啊，还有就是重量、高度，包括我们的后期用的那个设备，全部是世界第一的。这个有几个世界第一的这个世界之最嘛，就是。
Mr. Xu said one of the biggest differences is that there is a cement in those poles, and in construction of this tower, there are more advanced facilities and equipment, and so the tower or anything used in this tower is even more superior. So, 肖老师，我最后再问您一个问题：现在这个塔即将竣工，您现在站在塔下和我一起仰望这个塔，您的感觉是什么样的？
感觉也自己感觉很自豪，自己把这个世界第一输电高塔建设完成，是其中的建设者之一，建设者跟指挥者之一。那么从自豪呢，自己感觉很自豪了。
I asked Mr. Xu that looking up from the down as a constructor, as a man who led the team to build this tower, what's your feeling at this moment? And Mr. Xu said me nothing, but he's so proud of being part of the construction team and who has led the team in its construction of this tower. And he said he's very proud and looking forward to it into use next week. 好，感谢徐老师，谢谢您，徐老师。
So that was the highest tower. Now we look at the highest voltage DC transmission line.
We can hardly hear this. It's very much in the background.
Okay, so I just stop here. Then we can come into discussion and then we'll. So China's state grid, electricity grid, is the largest in the world. It transmits the largest amount of energy between different places, because the issue is most of the renewable energies is in the in the western region of China, and most of the commercial centers and the heavy industry is along the coast in the east. So that's why when we look at the map, you see a lot of horizontal lines carrying power from the west to the east. In order to carry a lot of power, to minimize the loss, we need to change the current to as small as possible, because from a little bit of physics, the loss of power is equal to the square of current times the resistance of the wire. For such a long wire, there have to be some resistance, and therefore I square R. So in order to reduce I, the current, then you need to increase the voltage in order to transfer the same amount of power, and that's why the voltage keep going up. At the moment, the highest voltage is 1.1 million volts. I think here in Australia, we are around 550,000 volts. So that will be half of the voltage used in China. And that means China's transmission will be at least 4 times more efficient, being double the voltage. But there's still a lot of issue here. For the wind turbine we talked about last week, the building of wind turbines usually talks about a month, about half a year, 5 months, then you will finish a wind turbine from design to installation, because you basically need to find a place which they know, usually near the local geology. They know where is the wind, and then it's just a matter of sending up some workers there, put in some pylons into the ground to secure it, and then bring the tower in, install the tower, install the turbine, and then there you go. You got a wind turbine. So a wind turbine usually takes about 4 months to 6 months. And if they are working on a wind farm, they can basically roll out one wind turbines every 2 or 3 days. So they are building up the wind turbines very fast. But connecting the wind turbines to the grid is a total different issue, because you are laying out a grid. The average time is 4 to 5 years. So one is half a year, and other one is 4 to 5 years. So by 2015, China has a lot of wind power which goes nowhere, which is wasted. So they need to build the grid in order to transfer power. I don't know what is the current state, so that is why next week we would like to discuss a paper, and I am going to copy the URL to obtain the paper, and I would like you to read that paper, and then we'll discuss that next week. So I will open up my here. So, and while I'm getting this ready, any questions?
Yes, Albert, what advantage do they get with the DC against the AC? Do they become economy in transmission, is it? And do they convert that back to AC at the end of the bigger lines?
Yeah, they will. Now, if you transfer a power over AC, the advantage is that you can easily step up or step down the voltage using transformers. So yes, there are savings at stations when you need to change the voltage. So there's the benefit of using AC, and that's why all countries started with using AC as the power transmission. Changing voltage for DC is very complicated electronic work. You need very high current transistors in order to do that, because you are talking about transferring a lot of power. So the power transistors is one of the limiting issues when people are designing DC circuits. But the advantage of the DC is that it has less loss during the transmission. Now for AC, when you're transmitting it, you have two kinds of loss. Of course, one is the resistance. The wire's resistance, that is the same between DC and AC. They both have resistance, so there is loss in the resistance. That's one. But for AC, there's loss also due to induction and capacitance, the two active losses. So AC lost more power than DC. So that's number one. Number two is that for alternating current running through a wire, you only use about 8 millimeters on the surface of the wire. So even if you have a very large wire, which is expensive, the current typically only runs on the skin about 8 millimeters deep. But for DC, the whole wire can be used to transfer power. And that's why DC typically has a smaller resistance compared with AC for the same wire. And therefore, you can transmit more power with less loss. And that's the reason why when you are transferring over really long distance, you probably want to use it over use DC. Okay, I'm opening up the chat group and send you a URL. So if you like, please download this from this website and have a read. We will discuss this paper next week.
Okay, will do.
Yep. But
Albert,
obviously,
can
I
I
will
also-
summarize it and then do a little bit of summarization before we discuss. But it will be better for you to read and then you know some issues first.
Can you also send that link in an email, please?
Okay, I will send that link in the email. But for those who are not on the Lunar Wedding email list, you might have to copy it from the chat now.
I can't see it.
Sorry.
It's
Click
gone
on
from
chat.
my
Click on chat.
chat. Right, I'll click on where's
Down
chat?
down the bottom.
Hmm.
Down the bottom of your screen, participants, chat, share screen, record reactions. Click onto chat.
I can't find chat. It's
Yeah,
it's hidden by all the
next to the participants.
No, not chat.
It's got more.
Or in more if you don't have open it up large enough.
Oh, more. Okay. Chat. Okay.
Yep.
Oh, got it.
Okay.
Guys,
Please
thank you.
have a read and then we will discuss this next time. Again, this is about the regulatory regime of wind and solar energy in China. So we're looking at what the government is doing. So we today we look at the China's electric grid is State Grid, which is a government-owned enterprise company. It operates like a private company, but except the main stock owners are the Chinese government. Okay, the CCP, the Chinese Communist Party, is major shareholders. So this company serves both to transfer electricity across the line, but also in developments of these electricity transfer technologies. So the 1.1 million volt AC transmission is an innovation by China. No other country is transmitting at this high voltage. Many of them is transmitting at about 800,000 volts, some at 500,000 volts. But China has done it to 1.1 million volts. Another issue is that when you have a high voltage transmission line working, you are transferring a lot of electricity from one place to other place. That means at the consumer end, if you have to do any maintenance on the wire, on the transmission, then that will mean there will be insufficient electricity supply at the end of the consuming. So for a maintenance work, they now have to work on a live transmission. That means the transmission is still running while they are replacing some elements. So this is again a very dangerous but very interesting technology. How can they a human being charged to 1 million volts and then work on the wire at that voltage?
I think they have special suits insulating and a Faraday's cage, don't they?
Yeah.
Faraday.
Yeah, Faraday cage. The suit itself is a very high tech development in order to be able to work at that high voltage. Because basically, if I remember when I was at school teaching electricity, we have an experiment and asking the girls, especially those with shoulder length hair, I like to call them out, touch that sphere, and then we charge her up. We will see her hair.
Yeah.
Is that what you used to do, Galbert? That was your.
That's what I
Well,
used to do when I was teaching electricity at secondary school. And the girls enjoyed it. And at that times, I asked the boys, don't touch her.
But I bet they did.
No.
Huh?
If they touch her, they will get a shock. And yeah, it's
If you
not
were
a
teaching it, if you were teaching in Australia, the boys would have touched them. Don't you worry.
you would definitely make sure that they don't, because it is life threatening. So I do need to charge up the girls and then discharge them correctly.
How do you uncharge them? They've got to have an earth, is it? They all touch an earth at the end of.
Oh no,
That
that will be too dangerous. We will have to discharge through the apparatus. Let the apparatus discharge. And while they don't take their hand off the apparatus. So as long as they are being charged up slowly and then discharged slowly, that is safe. The most dangerous thing is when they discharge very quickly. Then there's a large current flowing through, and that's where the danger is. So I have to make sure the girls I call up is a very obedient girl and knows what I'm asking her to do. So I have to explain very carefully what is this experiment, but this experiment is very exciting. Anyone want to volunteer? Among the volunteers, I have to pick the right girl. I don't want to risk a girl dying in my lap. But this will be the highlight of their class every year.
Yeah. And I take it you have to have something special insulation under their feet.
Yeah, I will ask her to put on a insulating mat.
Mm.
And stand on the mat, and then put her hand onto the apparatus, and then we slowly charge up. And then when it is charged to about 1,000 volts, her hair will start standing up. And then depending on how obedient the girl is, I would decide whether I will continue charging up to. The maximum voltage I charge up to is about 2,000 volts. I dare not go any higher because I don't want to have a corona discharge. I don't want to see her hair burning.
Goodness.
Albert, I'm going to make a move.
Yep.
Thank you very much.
Okay, so anyway,
Thank you. I'll see you next week.
Yeah.
At 12 o'clock, and then I'll see you next week at 1 o'clock.
Yep. Yeah. Really?
Happy Wattle Day, everyone. It's Wattle Day today.
Oh, yes, I can see you hiding there.
Yes, Wattle Day. Happy Wattle Day.
So what is Wattle?
Same to you. Same to everyone.
Okay.
All right.
Bye then.
Thanks very much, Albert. Bye-bye, all.
Bye-bye.
Very
Thank
much.
you.